Hello and welcome back to this channel. Dear students, today's topic is single phase series RC circuit. This is the topic related to the subject basic electrical engineering for first year engineering students. Earlier I have created the video on single phase series RL circuit. This is now RC circuit. RL stands for resistor inductor, RC stands for resistor capacitor. If you haven't watched that video, do watch that video. I will provide the link in the description box. Now, what is the question expected on this topic? Derive expression for current and power consumed for the circuit consists of R and C connected in series. Meaning is same. It is series RC circuit. Across V is equals to Vm sin omega t. This is the supply voltage. Now first step is we have to draw the diagram. It's very simple. It is similar to the RL circuit. So I have drawn R and C which are in series resistor and capacitor. Voltage across resistor is VR. Voltage across capacitor is VC. V is the supply voltage which is given in the question, Vm sin omega t. I is the current flowing through this. As the name indicates, it is a series circuit, means current remains same, whereas VR and VC, that is voltage across resistor and across capacitor, will be different, but current is same. Now first step is, I will tell you how to draw the phasor diagram. In case of resistor, VR is the voltage drop across resistor. For resistor, always in any circuit, do remember the basic concept. Current and voltage are along the same line. So, if I want to draw the phasor diagram on this axis, if I will say this is the current axis I, then VR is the voltage drop across resistor. As I said, VR and I are along the same line. Now, an important part. In case of RL circuit, resistor inductor circuit, voltage leads the current by an angle 90 degree. Opposite case, in case of series RC circuit, voltage across capacitor lags by 90 degree. So it is lagging by 90 degree. That means I will draw the voltage axis like this. This I will call it as VC, voltage across the capacitor, and naturally this angle is 90 degree. So very common logic, this is VR, that is voltage across resistor, VC is voltage across capacitor which is lagging. Since it is lagging, I have drawn it downward. In case of earlier circuit, RL circuit, I have drawn this vector in upward direction. Now V will be the resultant voltage. V is the supply voltage which is resultant or addition of VR and VC. So I will complete the diagram like this. I will draw this voltage as a resultant voltage V like this. This is the resultant voltage V and this is the complete phasor diagram. So this is known as the complete phasor diagram. What I have done, resultant voltage is combination of or addition of VR and VC which is drawn like this. Now do remember one basic concept, this angle is denoted by phi, and as shown in this diagram, resultant voltage V lags current by an angle phi, or in another way, current leads voltage, supply voltage by an angle phi. Anything will do. Okay. Now this is the complete phasor diagram. In the exam you should draw this complete phasor diagram which is pretty simple. If asked, if it is asked, if the question is like this, draw the voltage triangle and impedance triangle for series RC circuit. It is quite, it is again expected question. How to do it? Once you know this complete phasor diagram, from this diagram itself, I can generate the voltage triangle. How to do it? This is the complete phasor diagram. This line represents VC. This is the parallel line. So again, I will say this line is same as VC. What is that? Suppose I want to draw the voltage triangle for series RC circuit. Then this is VR, this is the resultant voltage V, and this voltage is same as VC. So I have marked it VC. Just remove this part. So this is known as the voltage triangle for series RC circuit. If separate question is asked related to voltage triangle, what do we need to do? Draw the complete phasor diagram and then draw this diagram, as well as don't forget to draw this circuit diagram. This is the voltage diagram. We know that basic equation of any voltage is current into resistance. So this is the basic equation. Current into resistance, which we know that V is equals to I into R. So VR can be written as I into R. Same technique. This VR is current into resistance. VC is voltage across capacitor. Resistance is the term related to resistor, whereas for capacitance, opposition provided by the capacitance is denoted by XC, and it is known as a reactance of capacitor. It is similar to the resistance, but it is the opposition provided by the capacitance. Any opposition provided by inductor or capacitor is known as reactance. Since it is capacitive reactance, opposition by capacitor, so it is XC. So this VC can be written as I into XC. Now, this is the values of voltage which I have expressed in terms of current and resistance. Similarly, this voltage V is equals to I into R. This is the resultant voltage. Now, if it is asked to draw the diagram for impedance, do remember impedance is denoted by Z. Impedance is what? Addition of all resistances. Look at the diagram. Here we have resistor and capacitor. Opposition provided by the resistance is R. Opposition provided by the capacitance is XC. In case of capacitor, it is R minus JXC. In case of inductor or in case of series RL circuit, this equation was R plus JXL. So this is the equation of impedance of series RC circuit. Now, if you want to draw the impedance diagram, see there are so many phasor diagrams. You don't have to mug up the diagrams. Very simple tricks I am telling you. This is the voltage diagram. Basic equation of resistance from this same equation. I will write it like this. Resistance is equals to voltage upon current. Now, if I want to generate the diagram for impedance, rather impedance triangle, how to do it? This is the voltage triangle. If I will divide each side by current, because voltage upon current is the impedance, then I will get the impedance triangle. So divide each side by current. If I will divide it by current, only R will remain over here. So on this axis, I will mark R. Similarly, if I will divide this value by current, then I will get eliminated. So only XC will remain. So this axis is XC. Similarly, if I will divide it by R, only R will remain. This axis is R. This is known as the impedance triangle, or make it more simple, you can write this as Z, because this is the resultant value. So this is known as the impedance triangle for series RC circuit. The next part is we have to derive the expression of power for series RC circuit. This is the equation of voltage given in the question. V is equals to Vm sin omega t. We just now discussed that the voltage lags current by an angle phi. In another language, current leads voltage by an angle phi. So if I want to write equation of current on the same lines, I will write it like this. I is equals to Im sin omega t plus phi. Why plus phi? Because voltage is lagging, means in another language current is leading by an angle phi. Say equation 2. Now basic formula of power, P is equals to V into I. So simply I will put the values. So it is Vm Im sin omega t into sin omega t plus phi. Now we just need to remember one trigonometric identity to solve this derivation. It's pretty simple. This is the trigonometric formula. Sin A into sin B is cos A minus B minus cos A plus B upon 2. So I have to apply this trigonometric identity for this term. So in this case, A is equals to, look at the first term, sin A into sin B. This is sin omega t. So A is equals to omega t and B is equals to omega t plus phi. It is sin A sin B. So B is omega t plus phi. Now its answer, it is cos A minus B minus cos A plus B. So I will just, for the simplicity, I will write A minus B over here. So it is omega t minus phi, which is minus phi. Omega t gets cancelled. So it is A minus B. Similarly, A plus B can be written as omega t plus phi, which is 2 omega t plus phi. Let us make use of these values to solve this equation. Therefore, P is equals to this Vm Im remains as it is. Vm Im. Now, this is cos A minus B minus cos A plus B upon 2. So, this upon 2 I will write it over here in the bracket cos A minus B. We have A minus B minus 5. So, I will write cos of minus 5 minus cos A plus B. Cos A plus B is this term 2 omega t plus 5. Now, one more identity. Everyone knows it. Cos of minus 5 is same as cos 5. So this is cos of minus 5. Simply I will make it cos of 5 using the identity cos of minus 5 is cos 5. This term can be separately written as P is equals to Vm Im upon 2 cos 5 minus Vm Im upon 2 cos of 2 omega t plus 5. So this is the equation of power for series RC circuit. This is not the end of derivation. We need to still calculate the average power. Now just observe this term. Here Vm, Im are maximum voltage, maximum current, 2 is constant, these values are constant, 5 is also constant. So this term is basically a constant term. Whereas this term contains omega. Omega is a frequency, so it is not constant, it is varying, it is changing, as well as it contains t, so it is changing with respect to time period. Now, if you want to calculate average power, so basic equation of average power is integration of the power, this equation. But do remember one basic concept. You don't have to solve entire lengthy integrations. Whenever you are integrating, this term is constant, so it can be taken outside the integration. I am simply talking about second term. What I said, do remember the basic concept. If you are integrating sine wave or cosine wave for one complete cycle, then answer of integration is always 0. So unnecessarily do not solve this integration. Directly you can write it like this in the exam. If you integrate cosine term for one full cycle, answer of integration is 0, so I am neglecting this term. After calculating integration, this term will be neglected, so only one term will remain. So directly I can write, and this is the constant term, so I can write P average is Vm Im upon 2 cos 5. Now I want to express these values in terms of RMS. We know that anything like V RMS or I RMS can be written as Vm upon root 2. Similarly, I RMS, I can write it as Im upon root 2. To obtain the expressions in terms of RMS values, I will split the equation like this: Vm upon root 2 into Im upon root 2 into cos 5. This term is 2. 2 can be well expressed as root 2 into root 2, because we know that root 2 into root 2 is 2. So I have got this Vm upon root 2 into Im upon root 2 into cos 5, but Vm upon root 2 is Vrms, so I will write it like this: Vrms into Irms into cos 5. So this is the final equation of average power for series AC RC circuit. So that is the end of derivation. Now, if it is asked to draw the voltage and current waveforms for series RC circuit, then how to do it? Again, this part is pretty simple. So to draw the voltage and current waveform, on this axis I will write time period. On this axis I will mark voltage and current. In the question, value of voltage is given as V is equals to Vm sine omega t. Just now we discussed equation of current can be expressed as Im sine omega t plus phi. Reason is current leads voltage by an angle phi. First, I will draw the voltage waveform. So voltage waveform is a standard waveform which starts from 0 like this. It is a standard sinusoidal wave because given equation is Vm sine omega t. So this value is pi, this value is 2 pi. Now Same way, this maximum voltage you should mark like this is the maximum voltage Vm. This is the standard sine wave. Now current is leading voltage by an angle phi. Leading means the current waveform should start earlier than the voltage waveform by an angle phi. So I will draw the current waveform like this, starting from this value. This value I will denote it by phi. So current waveform will start earlier than voltage waveform, and it will be like this. The amplitude of current is less than the voltage, so I have drawn less amplitude compared to Vm. So this maximum value is Im. So very simple trick. This is the way how you can show the voltage and current waveform. Now this part is pretty simple. You just have to memorize the things logically. We will solve one numerical to get an idea of this series RC circuit. The given problem is the series circuit having resistance of 5 ohm. Now while reading the numerical itself, be habitual of writing the values in terms of notation. So R is equals to 5 ohm. Capacitance of 150 microfarad. So it is 150 microfarad. Do remember, microfarad means it should be multiplied with 10 raised to minus 6 to convert it into farads. Is connected to one phase. This is one phase. It is read like this, single phase, 200 volt. V is equals to 200 volts, 50 hertz. F is 50 hertz supply. Calculate capacitive reactance, impedance, current, power factor, active power and reactive power. Purposely I have selected this numerical. So if you just solve this numerical, you will come to know how to solve any numerical related to RC circuit. So first part is calculation of capacitive reactance XC. Do remember this formula. Capacitive reactance is XC is equals to 1 by 2 pi FC. This is the standard formula. So simply you have to put the values. So it is 1 by 2 pi. F is 50 hertz. It is given in the question, into C. C is this 150 into 10 raised to minus 6. So if you just do this calculation on the calculator, this value will be 21.2206. Since it is reactance, its unit is ohm. This is the calculation of first part. Second, impedance. In case of series RC circuit, impedance is given by R minus jXC. We have the value of R. We have just now calculated value of XC. Simply you just have to put the values. So R is 5 minus J 21.2206. This is the value of impedance, but we are also supposed to calculate the current. To do this calculation, be habituated. Once you calculate impedance, be habituated of converting it into polar form. I have already created separate video how to make this conversion. If you don't know the procedure, you have to do it on calculator itself. If you don't know the procedure, do watch that video. So presently, I will convert it into polar form. As I said, you have to do it on the calculator. So this value in the polar form will be 21.8016 at an angle minus 76.74 degrees. Always and always make it as a habit, convert impedance in terms of polar form. So third part. In the third part, it is asked to calculate current drawn by the circuit. So current is I, which is basic formula V upon Z. V is the supply voltage, which is 200 volt. Here any angle or J term is not given, so I will write this 200 as 200 at an angle 0 degree. Whenever any angle or J term is not given, make it a 0. So 200 at an angle 0 divided by value of Z, it is 21.8016 at an angle 76.74 degrees, minus 76.74 degrees. Now many students get confused while performing such calculations. I will tell you simple trick. Whenever there is a division, this is known as magnitude. Similarly, this is the magnitude of denominator term. Perform normal division of magnitude. That means on the calculator you will be doing 200 divided by 21.8016. So first I will write this answer, 200 divided by 21.8016. So once you will calculate this answer will be 9.1736. Simply I have done the division of magnitudes. Now these are angles. this 0 degree and this minus 76.74. While performing division, if you have angle, perform subtraction. Subtract denominator angle from numerator angle. Numerator angle is 0 degree. So this subtraction will be 0 degree minus of minus 76.74. What I said, subtract denominator angle from the numerator angle. Minus minus become plus. So final answer will be this value I got after performing this division at an angle 0 minus of minus this becomes plus, so 76.74 degree. This is the final equation of the current. Next part, it is asked to calculate the power factor. So do remember the standard formula for power factor. PF is the notation used for power factor, which is given by cos phi. So this is the value we need to calculate. This angle is known as angle phi. So it is cos of 76.74 degree. Pretty simple calculation. So answer will be 0.2293. One more thing. Many students don't know, after calculating power factor, you need to mention whether it is leading or lagging. I will tell you the simplest trick. In any numerical throughout the subject, just check whether current is leading or lagging. In RC circuit, we discussed that current is leading. So in case of this, I will write in the bracket leading power factor. Very simple, because current is leading. So this is the calculation of power factor. Fifth part, it is asked to calculate active power. Active power means P, which is given by VI cos phi. These are all standard formulae. Only these formulae are sufficient, are required for RC circuit. So simply put the values. V means given voltage 200 into I. I means only consider the magnitude. While calculating power, do not consider this entire term. Only consider magnitude, that is 9.1736 into cos phi. Just now we have calculated value of cos phi. It is 0.2293 into 0.2293. So if you do this calculation on the calculator, the answer will be 420.7012. Since its power, its unit is watt. Now the last part, last calculation. It is asked to calculate the reactive power. Do remember this formula. Reactive power is VI sin phi. Same logic, you just have to put the values 200 into 9.1736 into sine of angle phi. This is angle phi, 76.74 degree. So if you solve this on the calculator, this answer will be 1785.81. Again, its power, so its unit is watt. So that's it for today's session. Dear students, just for RC circuit, you need to prepare this thing. You will be in a position to attempt any question. So thank you. Thanks a lot.